Thank you, Marty. It's a wonderful introduction. So Computers Unlimited's journey into continuous integration. First off, a little bit about Computers Unlimited. We were founded in 1978 in Montana. I actually just changed the slide. I thought we were always based in Billings, Montana, but I was doing a little bit of research, and apparently we actually started in Bozeman, Montana, shortly before moving to Billings. The company as a whole is about 190 employees. That includes everyone from our support department to accounting and whatnot. But about 90 of those are in development, so we've got a large number of developers. Our primary product is a product called TIMS. It's an acronym. It stands for Total Information Management System. And we target the industrial gas and welding supply distributors. So you know, if you need to buy an acetylene torch or a cylinder of medical grade oxygen, a lot of those companies are using our software to manage everything in their business, from payroll to accounts receivable to general ledger, cradle to grave, really. So a little bit about me. I got my Bachelor of Science in Computer Science with a minor in Business Management from Rocky Mountain College. It's a small little college that's based there in Billings. I started as an intern at Computers Unlimited in 2007. They put me in the regression department, and you heard Tim and Marty talk a little bit about what regression is. Basically, a lot of automated testing. So a lot of my background is really strongly focused on testing and processes. So one of the things I love to do in my spare time is break things. That's why I tend to post a lot on the community forums once we find something. I've been the build master there since 2010. When I started, there was DevOps wasn't a buzzword, or really DevOps has always existed. Just we didn't have a real fancy name to give to it. These days, I'd probably be like the lead DevOps guy, but I like build master because it's got master in the name. I'm a Microsoft certified associate. You know, we did that because TIMS is, or Computers Unlimited, I should say, is a Microsoft Gold partner. It helps us a lot on our MSDN licensing. So quite a few of our developers are Microsoft certified associates. And I'm also a big Simpsons fanatic. I don't tend to post it too much on the community site, but if you ever get into like a Slack chat with me or some private messaging, you'll see I use a lot of Simpsons memes all the time. So let's talk a little bit about TIMS before we kind of talk about our journey. Like I said before, TIMS is an acronym, stands for Total Information Management System. And let's talk about the stack. The stack is very, very deep, very, very complex, very, very integrated. At the bottom point here, I say it, the list goes on. If Microsoft or Synergex put forth a technology, we probably used it. And I also like to add on, we probably abused it. So I mean, everything from Synergex, you know, Synergy DE, obviously, toolkit, repository. I mean, we drive that repository hard. XF Server, XF Server Plus. You know, the day that somebody figured out that the .NET interop was a way to get over to the C# LAN, you know, that went out of control. You know, selected Microsoft technologies. We've got a lot of C# developers. You know, .NET 4.6.1, a lot of T-SQL. There was a big push. I think CU was probably one of the first. Don't totally quote me on that, but I'm going to say we were probably one of the first to make a giant leap into SQL databases. So all of our data is in a T-SQL database. Windows Form, Windows Presentation Foundation. Anytime some new cool UI came out from Microsoft, UI framework I should say, came out from Microsoft, it's like, yeah, let's go do it. We're going to rewrite everything. And you'll see how that worked out. Some of our newer stuff, we use a lot of Windows Communication Foundation. We host that in Internet Information Services and IIS. So, you know, Entity Framework, Unity Container for dependency injection. You know, some older stuff, VB6. You know, when VB6 was new, somebody had the bright idea. It's like, oh, we're going to rewrite everything in VB6. And they didn't quite get there. SQL reporting services, .NET Compact Framework. I'm not even going to cover our mobile stuff. Needless to say, huge. Talking about the code base, like large, extremely large. When I started working at CU, it was kind of mind-boggling to me just how large the code base was. You know, on the Synergy side, 11,000 files, 4.6 million lines of code. and a little over 1,900 projects. And on the C# side, you know, similar, very, very similar. And I mean, so for comparison, I have the Linux kernel up there from 2017 to kind of give you an idea just where we stand and how it compares. My bottom point here is, oh yeah, this is just per version. So if you look at our software, we have multiple versions of our software, kind of split along mainline versions. So we have TIMS 4, TIMS 5, TIMS 6, TIMS 7. And with each of those, because we have so many customers and we need to maintain kind of longer term support, each one of those versions has like a point release. So 7.0 has 7.0 R33, 7.0 R34, 7.0 R35. So we have 3 of those. So a lot of branching, a lot of merging code between branches. It's incredible. It's crazy sometimes when you look at it. So I've got a couple of screenshots of our software. So this is this is the menu. Looking at a lot of your guys' software, you have something similar. I obviously don't have anything pinned in my little favorite section, but this is a WPF app. This is one of the newer portions of our code. Years ago, we decided, hey, you know, this is the first thing our customers see. We want it to be a, you know, kind of modern-looking experience. So this is menu. The next one is inventory items. This is another, you know, WPF C# application. All this data is stored in the database. There's no synergy here necessarily. When you get into like pricing, there is an XF Server Plus call, so there is some synergy kicking around there. You have AR Manager, so this is getting a little bit older. So this is like a WinForms application. Once again, it utilizes XF Server Plus in the background to pull pricing information and a couple other things. Here we have order entry. This is like the heart of our system. Just about everything starts with an order. So this, as you can see, this is still a traditional Synergy Toolkit application. But if you pay really close attention, you'll notice that that grid is actually Infragistics grid that was integrated at some point. And then finally, getting to the oldest part of our system, you've still got a few, not too many. I actually wasn't going to put in this slide, but Ryan pointed out to me, he's like, we've still got some old, I call them SMG apps. I guess I've heard them called character or cell-based applications. We still have a few of these kicking around. These are kind of high priority for us to rewrite into something a little more modern. So let's get into the heart of my, so now that I've explained a little bit about what TIMS is, kind of what we're dealing with, what is continuous integration and why do I care? So if you were to go Google for continuous integration, just about everywhere is going to show you this, this really cool looking graph. And basically it starts in the bottom left-hand corner. We've got you know, our developers that are sitting here all day constantly programming code. So the step one is they're going to check in changes into some kind of source control system. And then from the source control system, a build server is going to go fetch those changes and it's going to start this cycle. I'm going to build your code, I'm going to test your code, and then depending on if it fails or succeeds, I'm going to report that back to the developers and the whole process is going to start over again, just in a continual loop. And this is it's a really important concept because when you have as many developers as we do, I mean just every day, I think we have something like 100+ commits a day to the system. So we want to be continuously building that code that's coming in because you have no idea if your code is going to go break. You know, I have no idea if my code is going to go break Ryan or if Ryan's code is going to go break, you know, some other developer within the company. So we want to try and isolate that as soon as possible once we've introduced a breaking change. So there are a couple of key concepts, and none of these concepts are new or unique to CU, to Computers Unlimited, but I'm just going to kind of focus on what I feel are really the guts of continuous integration. The first one is maintaining code in a version control system, having a single build step, build early, build often, and build fast, make the build visible to everyone, make it easy to get the latest deliverables, and then continual improvement of the process. A lot of these points come from a great blog post by Joel Spolsky. I've probably butchered his name and I apologize. But he has a great blog post, which I'll reference at the very end of my slide, that he wrote in 2000, where he laid out various points of the bare minimum of what he considered to be, to call yourself a professional developer. And a lot of these points were on his slide. So our first slide here is maintaining code in a version control system. We've heard a lot of people talk about various version control systems here, and I would hope that most, I'm not going to make you raise your hands, but I would hope that most of us here have some form of version control, be it Git, Subversion, Mercurial, there's tons. PVCS, I know was a popular one with us, back years and years ago. It really doesn't matter what version control system you use, so long as it allows you to quickly see who's making changes and pinpoint when those changes were. But like I said, there's plenty of options out there, and I'll talk about what CU uses in a bit. A single build step. Why do we want a single build step? Well, there's nothing worse than a complex set of steps. I mean, if I'm a brand new developer coming into your world, the very first thing I'm going to do anytime I step into a new piece of code, if I go grab something off GitHub, the absolute first thing I do is I pull your code down and I try and build it. And if I can't build your code by simply hitting build or by executing one line of code, I'm probably going to get frustrated really, really quickly. Scripting to the rescue. Ideally, in a perfect world, I should be able to open up your solution in Visual Studio, hit build, and be off and running. I shouldn't have any kind of build failures. I shouldn't have any additional setup I need to do. I should just be able to open it and build. Or at very least, I should be able to open up some kind of batch file and say, run. And the important thing with a single build step is remember the KISS principle, which is keep it simple, stupid, or smart, depending on how facetious you want to be. If you don't make it simple, people are going to give up. They're going to get frustrated. They're going to start playing around on their phone. Especially younger developers, they're going to be there and they're going to be like, oh, this is terrible. I'm going to start blogging about it, and that gets people in a real negative place. Document. Writing documentation is never cool. It's never fun. But a lot of times, people who are motivated, like when I run into a problem, the very first thing I do is I go start looking for documentation. I'm like, I'm not doing anything unique. Somebody else out there had to have ran into this problem before. So I start looking for any kind of documentation. We'll talk a little bit about that. And then again, I can't stress it enough. Keep it simple. Try to use industry standard tools. MS Build, Make, Ant. It doesn't really matter. Just use something off the shelf. So many times, we kind of get into that mode of like, oh, it's not great because we didn't build it here. It's like, no, you don't make any money. I mean, I don't think any of us in here work on developer tools beyond Synergex, obviously, but that's not our bread and butter. We want to spend as little time as possible developing our own tools. We want to offload that to the open source community or to Synergex or to somebody whose job it is to produce these development tools that we use. Build early, build often, and build fast. So, I mean, why? Like I said earlier, CU, between 70 and 100 changes a day. If I have to sit there, even if every build, only takes an hour, I'm only going to get 8 spins a day. So we want to try and make that as fast as possible. So how early is early? In a perfect world, if I'm a developer and I make a breaking change, I want to have it break right in my IDE. So if any of you have used C#, you realize that as you're typing, you're going to get that cool little red squiggly line that says, hey, you've done something wrong. In the Synergy world, we don't have that yet. We're still pushing for it. But at very least, as a developer, I should be building my code constantly in Visual Studio. And that's where that integrated development environment is really helpful. It's helpful for me not to have to go out to the command line, not to have to switch a window. I want to just be able to hit one hotkey, F6 in Visual Studio is what it's bound to for me is build. And I want it to build. And if it breaks, I should fix that immediately. How often is often? As a developer, when I'm developing, I should be, constantly, just about every, 30 seconds after I finish some piece of code, it's just muscle memory. I'm hitting that F6 button. I'm trying to build. It's like, well, did I break anything? Did I break anything? In the continuous integration world, basically, it should be on every commit. Every commit in a perfect world should do a build. And the reason that you want to do that is that if you've introduced a breaking change, if you're doing it on every single commit, you immediately know if the build was working and now the build is broken, it's obviously this guy's commit, right? You're reducing the number of places you've got to go look for a change. And then how fast is fast? I mean, really it depends on the scope of your code. And we'll talk a little bit about CU. In an IDE, you really want that build to be about a minute or so. And this is kind of where that continual improvement is. You always want to make it faster. You never want to be sitting around waiting for a build. Making the build visible to everybody. Well, why would I want to make the build visible to everybody? So when the build breaks, you want it to kind of be a big event. You want people to be coming up to you and saying, well, why is the build broken? What have you done to break the build? And it's not meant to belittle you or whatnot, but it's that serious. So it really incentivizes people to say, well, I don't want Ace chasing after me if the build's broken, so I'm going to try and build as much as possible locally so I avoid hearing from Ace. How do you maintain this visibility? There's tons and tons of ways to do it, and I'll show you our particular software package that we use gives us a couple of options. We can send an email out to the developers, there's a website that everyone can go to, and there's a little application that basically anytime there's a build failure, it pops up a little message that says, so-and-so broke the build. And in that little tray application, you can right-click and say, okay, I'm fixing the build. So that communicates out to everybody that, hey, I saw I broke the build, I'm working on it. Build breaks should be serious events and handle priority number one. The turnaround time on a build break should be immediate. It shouldn't be like, oh, I'll take care of this after this meeting I'm going to go to, or, I always have a rule, no 4 o'clock check-ins, because if you check in at 4 o'clock, that means I'm not going to get a build overnight and nothing's going to be fixed until the next day. It's like if you break the build, you need to drop whatever you're doing and you need to immediately fix the build. Make it easy to get the latest deliverables. So why is it important for us to get the latest deliverables? After the build is done, that's really just the beginning, because the very next step we're going to do is we're going to want to test. And in order to test, we really want to understand where the binary comes from. So in a continuous integration world, we can say, hey, these particular binaries were built against this particular change set, and we know exactly what's in it, we know where it came from. It's not some magical, oh, this was copied from developer X's PC and developer's Y PC, and developer Y was maybe a little disgruntled and decided to put some real dubious code in there that transferred everyone's credit card numbers off to this little private server in Russia or whatnot. But in a continuous integration world, you know exactly what's in that binary. All those machines are locked down. There's no question as to what's in there. Another key tenet is every build should be deployable to customer. There should be no reason that your processes to create your deliverables are different between producing a build for your QA guys and a build for your customers. And that gets a lot of really big advantages, especially for us. It allows us to very, very quickly, I mean, within a matter of, if we had a serious data corrupting bug, probably within about an hour, we could ship to our customers a completely new version that fixes that bug. And then finally, automating the deployment process. That's huge. A lot of what Donovan talked about is automate, automate, automate. Automation's cheap. It's expensive to get into, but once it's there, I don't have to pay my servers a salary. I don't have to worry about them getting sick. I don't have to worry about them, getting disgruntled with me. They're going to sit there and continually grind away. The final point is continual improvement of the process. So why? If we're not continually growing or evolving, we're really dying is what it is. Our industry moves so fast. I mean, even just in the 8 years since I've been doing this, it's amazing to see the types of tools and processes and procedures that have come out just in the 8 years. But like I said, we really need to evolve and stay up with the current track. Pay attention to feedback. This is kind of something that was touched a little bit on in Jackie's presentation. When you have new developers come in, they're going to be your greatest source of feedback because everyone that's been at your company for a while, they understand the system And a lot of times we don't realize just how terrible a process might be. To us, it might not be a bad deal to open up, 5 different windows to build or deploy to a customer. Well, when a new guy comes in, he doesn't know what's normal, he doesn't know what's accepted, and you really need to listen to his feedback and try and understand, okay, there's obviously some process here that's not quite right. And you got to be a little careful with that, because sometimes you just have a new developer that, that's just the way it is. But a lot of times, if you take a real good listen to what they're saying, you get some incredible feedback. Keep current and get involved with the community. So part of the reason I post so much on the Synergex forum is I see that as a way for us to enact change in our processes. And like I've said before, I'm not the, I'd like to think that I'm the dumbest guy in the room. Somebody else smarter than me has figured this out. So I've often said that if I post enough, somebody somewhere is going to have a good answer. And for us, CU's kind of in a unique position. Part of the reason that I'm also able to post a whole lot on the community forum is that literally is my job. I'm responsible for ensuring that all of our stuff builds and all of our stuff integrates. And I've got, basically 90 developers behind me that every day I'm listening to their feedback, and they're telling me things they're running into. So then it's my job to go kind of run out, narrow down that case, and then post something on Synergex or Microsoft or whatnot. So don't think I'm some super guru out there that all I do all day is go find bugs. A lot of what I've reported is coming from other developers that I'm just simply a conduit which that flows through. And then blog and document your experiences and share them with others. It's hard, right? Because there's no immediate benefit to doing something like this. It's very expensive and time consuming to sit down and write your processes out, kind of explain what you're going through. But it's amazing. I mean, I'll go back, years, and I'll show you that in a little bit here, years after I've ran into something, and then encounter a blog post that I've written that's talked about that. And it's like, well, this was my thought process at the time. And I'll reevaluate. It's like, well, are my assumptions still valid? If they are, then this answer is good. Or maybe it's like, hey, this process has changed. There's a better way to do this and improve upon it. So now I'm actually going to talk about Computers Unlimited's journey. So basically, the first part of this presentation was just kind of talking about CI in general, the basic tenets. And now I'm going to talk about what Computers Unlimited did to kind of address all these points. So I'm going to start this slide out here with a preface. The stories and information posted here are artistic works of fiction and falsehood. Only a fool would take anything here posted as fact. So it's just my way of saying this is Ace's view on it. This is what my experiences have been. I'm sure you can feel free to talk to Ryan. He'll give you the real story, or anybody at CU. And I love memes, so I loved this. Someone wanted to go back in time. This is not a joke. Your safety is not guaranteed. I've only done this once. So maintaining code in version control. So from copy and pray to patches and branches. So if you look at the history of CU, thankfully a lot of this stuff happened before I was even born, which is great. It's funny to work at a company where a lot of the guys that are working there have been working there longer than you've been alive. So from 1978 to about 1995, we had the copy and pray method, which basically was we had some file share out there, and there were multiple versions of the code, and everybody would make a copy of it. And when you went to go integrate it in with somebody, you'd copy right over it. And man, you'd sure hope that whoever was copying over it had the latest version of your code, because if not, your code was gone. And then you'd have to hope that you had a copy somewhere else. Sometime in 1995, somebody got real smart and found a copy of PVCS and ended up getting that system rolling out. I have no experience with it because it was kind of before my time. So CU is, because we're so large, we're split up into several groups. And a lot of what I'm talking about here, a lot of it was pushed by a group called the ET group, the Emerging Technologies group. So somebody around 2001 decided, hey, I don't like PVCS, let's look at Microsoft's solution. And they came up with SourceSafe. The joke around the office is it should really be called Source Unsafe because of all the issues we had with it. In 2006, once again, somebody's like, I'm tired of losing all my source and SourceSafe. The database got corrupted and I'm totally hosed. So someone's like, okay, let's switch to Subversion. And then, now the latest and greatest is Git. Everyone's like, let's get to Git. So we'll see where that goes. It's on my list of stuff to do when I get back. So let's talk a little bit about subversion. So I don't know how many of you are familiar with subversion, but we're going to kind of go through it. So why subversion? I mean, it's free, it's open source, it's great. They're actually very, very responsive to bug reports. Believe it or not, I've reported, I think, 3 bugs to them, and I'm very proud. I actually have a security vulnerability report attached to my name. I was able to find a way to remotely crash a subversion server, so I was very happy about that. It's well established. It's been around since, I'm going to say 2001. Don't quote me on that, but I'm pretty sure it was 2001. Extremely low learning curve. It's actually based on a very similar to CVS, concurrent version system. It's easily extensible, commit hooks galore. If you were to look at CU, we've extended, using the commit hooks, we've extended it incredibly. Like when you go to check in code, it'll check to say that, hey, you know, do you have a work order associated to this? Did you make sure that all your code, you know, was using tabs instead of spaces? Did you bump the version on this? And if any of that is not true, it immediately kicks out your, it doesn't even allow you to commit. It says, hey, you know, you broke one of these rules. It can be a little painful sometimes, but it really helps enforce code quality right at the beginning. And this last point here, it's centralized. These days, it's, you know, the new hotness is Git or any kind of distributed version control system. There's a lot of noise around that, and for some people it works great. For our company, I mean, I'll tell you right now, our subversion repository, like the actual repository structure itself, I think is like 12 gigs, and we're not real excited about cloning 12 gigs of history. Now, in Git's defense, it's gotten better about shallow copies and whatnot, but we won't get into that. We're not talking about Git. So here's kind of a screenshot of, this is called Tortoise SVN. Basically, it's a GUI front end on Subversion that kind of allows you to see, you know, what's committed. And as you can see here, we've got some version history. But, you know, we can see, you know, several developers making changes to code, you know, and what they're changing. I could double click on any one of those and get a diff. So a single build step, you want to do what now? So from 1978 to 2010, when I started, the first response I got from a lot of people is like, well, do we have the ability to build our code from scratch? And they actually laughed at me. They're like, well, why would you ever want to do that in a million years? I'm like, well, how do you know what you have is valid? They're like, well, you know, we've got a pretty good copy out there. It's like, no, we gotta fix that. Before then, so from 1978 to 1994, it was basically command line compiling. Someone would log out to one of our servers where the source was, and they'd sit there and they'd run, you know, db link or whatever the command was before we got to Synergy. They'd sit there and run that. So then in 1994, somebody got a bright idea and said, okay, you know, I'm going to write a tool because I don't want people logging out to that server anymore. And they called it DC, direct compiling. And basically what it allowed you to do is from your developer PC, you'd run this tool, it'd go SSH or I guess Telnet, not even, probably before SSH, it'd Telnet out to the build servers or to the servers in question and perform a command line compile. Then in 2004, somebody in the ET group actually was like, okay, you know, let's get a little bit better than that and let's continue to wrap Synergy's tools in a tool called DBC. And what DBC was is it looked at the Synergy, because at that time we were using Workbench, so we were using Workbench project files. What it would do is it would take a look at the project file and say, okay, based on this, I know I need to compile all these source files. So then when I came around, I ended up putting an MS build wrapper around DBC that would basically invoke DBC and invoke everything that we needed to properly build. And then in 2017, and you know, huge kudos to Marty and everybody at Synergex that worked on that project. We were able to use all the work that Marty and company did for traditional Synergy and Visual Studio and basically leverage it directly from MS Build. So the build system itself is MS Build based. You know, it's Microsoft's answer to Make and Ant and you know, various other build systems. But basically, there is one single line that allows me to build everything, all of our C# code, all of our Synergy code, all of our Synergy.net code. Literally one simple command line that, hey, this will build everything. That /m, by the way, is very, very important. That says do it multi-threaded, because if you don't, you're going to have a bad time. But we've got tons of helpful batch scripts, so it gets us to a single double click and, hey, I build the world. But hey, you know what? What if I don't want to build the world? You know, I work in order entry all day. I don't care about, you know, general ledger. I don't care about customer centric. I don't care about any of that. Well, this is where traditional Synergy in Visual Studio was really, you know, a dream come true for us. And what I have here is I have a screenshot showing basically we've got a little solution file that says, hey, here's order entry solution. I want to get in here. I want to work in order entry. I open up one solution. Bam, I've opened up order entry solution, and I've opened up the 26 dependencies that I have. So now as a developer, when I'm looking to go make a change, all I have to do is hit F6, or I can hit F5, and immediately I'm dropped into order entry. I can make my changes, I can test my changes locally. If I break something, I know what I've broken. So for us, this was huge. A lot of our developers come from a C# world where this is kind of the norm. And at first, you know, if you talk to a brand new C# developer and you say, oh, this is, you know, we just got this, it's amazing. They look and it's like, well, didn't you always have that? It's like, no, you need to understand this is something really big for us. So moving right along is our build early, build often, build fast, and don't break it. That's the other rule. So if you look at this very, very busy graph, it's a little pretty graph I made years and years ago to kind of help our developers understand how our process works. So as you can see, very similar to that little diagram I showed you at the beginning, it all starts with the developer. You know, the developer checks in code to subversion. The build's automatically going to kick off. It's going to go to the build system, build code, successful build, nope. The build is going to somehow notify the developer. Usually it'll email it, or, you know, I watch that like a hawk. I'll email it. Fixes the error, you know, process starts again. So successful build, yes. Okay, so now we copy to the output. So the process I'm going to talk about today, that's actually where my world ends. But like I said, after the code's built, that's not the end of it, right? So now it actually goes off to another team in CU called the distribution team. And then the distribution team, their entire world starts from a build output. So every build is built off a subversion revision. There's a little folder out there that's got a revision number and says, okay, this is the build against, you know, revision 15, let's just say. So from there, they're going to start their process, and all their processes are automated as well. They'll go and basically create an MSI and then successful. Once their process is successful, and like I said down at the bottom here, it takes about 15 minutes for them to do that. And then from there, we get to package deployment. So, you know, a tester, a developer, or distribution requests a new installer. So, hey, I fixed a data corrupting bug. I need this out there in our test environment. So, you know, we send an email out to all of our testers, say, hey, please get off our boxes, and everyone logs off. We kick off an installer. It totally reinstalls our product, and, you know, if it's success, hey, we're ready to test. All of our testers can go out there and do it. And I don't know how well you can read it, but as you can see for our package deployment, this happens every night. Basically, at most, it's a 24-hour turnaround time. From the time you cut code to the time a tester is sitting there banging on it is 24 hours for manual testing, at least. The build itself actually runs a whole slew of unit tests. It was kind of interesting to hear Donovan talk about, oh, you know, we've got 86,000 unit tests, and I took a peek to see how many unit tests we have, and just in our C# code, I think we have 76,000 tests, and in our Synergy side, we've got, I'm trying to remember the number now. I want to say the number was like 12,000 unit tests, so we've got a lot of tests. You know, so how fast is fast? So at the time when I wrote this, there was a lot of rumbling around, hey, it takes an hour and 30 minutes for a build to go through. Well, you know, thankfully, working closely with Marty and actually getting some better hardware and more cores, more memory, we've actually got our build down to about 40 minutes. So this process just continues to shrink down, and we really want to get it down to about 30 minutes because we figure 30 minutes is a good number to shoot for. So make the build visible to everyone, and once again, and don't break it. So the main tooling that we use to kind of kick off the build process and keep visibility on it is a tool called cruisecontrol.net. And it's a free open source product. It's great. You can watch them out on GitHub. This is like the original continuous integration product. I put original in quotes because the Java version was, this is actually a port of the Java version. But the way I explain it to people who are not familiar with it is basically this is like Task Scheduler or cron on steroids. Like, I mean, everything you do in cron with scheduling, triggering, whatnot, can all be done in cruise control. But it's got so many awesome plugins, and because it's open source, we can easily extend it. And once again, because it's open source, we don't have to pay licensing. We can deploy it to as many servers as we want. We can hack it up all day long. So here's kind of a screenshot that shows you the 7.0 development build, and each one of those little numbers there represents a build that kicked off. And obviously the ones in a red, or I guess it looks kind of orange there, indicate a build failure. So as you can see, generally when a build breaks, it's fixed immediately. Sometimes you get little spurts here, and here someone's doing a 4 o'clock check-in. Shame on them because it failed overnight and then failed the next morning until I got in and started complaining at them. But the great thing about this is it sits there constantly checking for changes. Every 30 seconds, it's like, do I have any new changes in subversion? Do I have any new changes in subversion? If so, he kicks off and starts running. So here's this, so it's got a little add-in called CC Tray. What this is, it's just a little program that sits down in your taskbar or system notification area, whatever they're calling it these days. And basically it allows you to kind of sit and monitor builds. So remember how I said we have a large number of versions? Well, for every version of our product, we actually have an instance of cruise control spun up. And I'm just monitoring a few of them now. I think I did a count at one point. I think we have something like 120 virtual machines that are just sitting there every day, asking for changes, trying to do builds. And the part I love is like on some of these, you get to see who the breakers are. So here, Bill, Darren S., Jason U., Andrew. So when this goes to red, I'm gonna start talking to those guys and be like, what's going on here? Why is this breaking? And one point I didn't touch upon that's really important. The other reason that you need to be fixing your build break is this needs to be reliable. Like if your build is constantly broken, it's like Donovan mentioned, it just becomes noise. Developers are like, well, the build's been broken for, who knows how long, what's one other break? I don't care about that. But if the build continually runs clean and you're constantly breaking it, I mean, we're gonna figure out real fast that, hey, this developer either needs more training or we need to understand what they're doing because you shouldn't be breaking the build. So once again, this is all stuff that comes out of the box with cruisecontrol.net. I didn't have to do anything at all to get all this. And this is probably far too small to read. But I mean, it's doing stuff like it's keeping my unit test counts. It's telling me how many unit tests failed, how long a build was taking. Really a great tool. And then because it's extensible, we're able to get our own build statistics around it. So one of the add-ons that I've written, I used Google's API to develop a cool little looking chart here to break down and say, okay, how much of our build is consumed in certain parts of the process. So if you look at our build system, because we have so many technologies, they're actually split up pretty logically. So I can tell you exactly how long it took me to build the Synergy portion of the build, how long it took me to build the Synergy.net portion, or TimsNet is our C# stuff, Fusion's our absolute newest stuff. How long did it take me to deploy? And as you can see here, and I'm actually very proud of this, it took us only 17 minutes to build all of our Synergy code, like every single piece of Synergy, complete, fresh, clean build. And when I started back in 2010, I think it took us something like, maybe it took an hour to build Synergy, just the Synergy portion. So the build itself was, ended up being an hour and 30 minutes. But I mean, once again, I can't stress this enough. Through the hard work of Synergex and Marty and the entire team there with traditional Synergy and Visual Studio, we've been able to bring that build time down to something much more manageable. And that's done through building in parallel, improvements to the compiler, whatnot, just a continual improvement. Once again, because it's extensible, I can make all kinds of charts. I can say, in this particular case, what I'm doing is I'm looking at warnings. I'm saying, okay, where are the vast majority of our warnings? And when you can start visualizing data like this, I think we've got something like 70,000 warnings. And at first, when I told that to our developers, they're like, oh, 70,000 warnings, this is just noise. And it's like, well, if we start breaking it down, and if we start kind of taking these, these smaller slices of the pie out, it becomes more and more manageable. And it also kind of helps us understand, it's like, where are most of our warnings coming from? I'll be honest with you right now and tell you that the number one warning is CU 2009. It's actually a warning that we implemented, and the warning is you didn't use a descriptive enough variable name. So then, the question becomes, now that I have data, now that I can show you this pie chart, I can go back to our programmers and say, okay, we obviously wrote this warning. It's just become noise. Why don't we just get rid of it or go fix it? Making it easy to get the latest deliverables. So we want a single reproducible drop. So from 1978 to 2007, it was a complete manual deployment process. The first time somebody explained the process to me at CU, I was just totally shocked. And I'd be interested to know, once again, I don't need to see a raise of hands, I'd be interested to know how many of you use this kind of deployment scenario. Basically, what it came down to is a bug would come in, a bug would get fixed, they'd produce a binary on a developer's machine, and then somebody would dial out, either telnet out or FTP out. They'd take that single binary and they'd drop it on a customer's box. Just like, wow. I mean, I had a million questions like, well, how do you know that this guy that was deploying it was deploying good code? How do you know that it wasn't like some hacked up binary? I mean, how do you know on that customer's machine, what version, where did this binary come from? Did the developer have like a local change that he forgot to check in? So on and so forth. So once again, in the ET group, somebody in 2001 said, okay, this is terrible. So for their .NET code, they produced an MSI, basically used an install shield. And that worked really great for them. They could tell you where it came from, what revision it was built against, and it very easily we could look on a customer's box and just say, hey, they have this version of code, the fix for their bug is on this version, obviously they don't have it out there. So in 2007, the distribution group made a really big push to get to what we called the unified MSI deployment, and that's taking all of our Synergy binaries and all of our .NET binaries, putting them into one giant MSI, and deploying it out. And they ended up using Wix to do that. And you've heard Wix, mentioned a few times here. It's great, it's free, it's open source, everything's in XML, well documented. You can check it into subversion. You treat it just like code because your installer really is code. So yeah, Wix installer, open source software. You can check them out, wixtoolset.org. XML-driven creation script, and every single build can have an installer created for it. And for us, like I said, this is huge. We want to be able to immediately ship a fix to a customer, and we want that fix to be reproducible. So because of that, we need an installer. And for us, it's no big deal to cut an installer. And then there's no difference between an MSI or an installer created for testing and development and for our customers. They are exactly the same. So our processes is basically we have the build run, we decide to choose a revision to land on, and then we say, okay, testers, test on this, test on this, test on this. And then if they're totally validated, they're totally good, then that exact same installer, we don't do any kind of touching to it or whatnot, we ship that right out the door. So for every single version of our software, we'll produce an installer. And once again, you can't really read it here, but all of our installers have the subversion revision number appended to the end of them, so we know exactly, we can say, hey, this particular installer was built against this revision, we know exactly what's in it. And they kick off, at 2:30 a.m. in the morning, because it's totally automated, some computers sitting there grinding late at night. And we come in the morning and we have new installers that we can mess with. So continue to improve the process. Like I said earlier, get busy living or get busy dying. Key concepts. Once again, paying attention to weak signals. These are your best indication that something's amiss. If a new guy is coming into your development shop and he's just totally frazzled, there's probably a reason for that. And a lot of times, I don't think we spend enough time to kind of sit and listen to their concerns, because a lot of times when you're hiring somebody, you're hiring them because you're behind on a project and you're just trying to move fast. And after a while, these developers, the ones that make it, they end up accepting the madness. They're like, well, it's just the way we do things here. It's never going to change. So, how do we fix that? If you bring passionate people into a process, they kind of self-govern themselves. And I think, for me at least, I've been told this many times at work, I'm super passionate about what I do, obviously, right? And sometimes that can rub people the wrong way. And it's a continual learning process. So I would say be patient with your newer devs. They're not here to totally unseat you, but they're here because, and if they're coming to you, they're probably coming to you because they're passionate enough about it, and they want to improve the process. They want to see you succeed. They want your company to succeed. I mean, Computers Unlimited has been here for 40 years. I mean, there have been people that their entire career has been at CU. And me personally, I would like to have my entire career at CU. But I know in my heart of hearts that if we don't evolve, we're not going to be here for 40 years. So document. I can't stress this enough. Document every single error you see, because chances are you're going to run into that error at some point. Lately, and I'll cover it in the next slide, I've become a big fan of saying I don't care about like long written out documentation that says how to do something. No one's going to read that. What I care about is when I get this error, what caused this error and how do I fix it? Because that's all I care about. I don't care like, well, if you had just read the original setup doc, you would never get this error. No. I'm going to run it. If it falls over, tell me exactly what I did wrong and how to fix it, and then let me get into the next error. Read. I mean, you want to stay current. Continue to read as much as possible. I mean, see what other people are doing. I've constantly said we're not doing anything new or unique or like way far out there. We're not doing any AI development or whatnot. Other people are running into these exact same problems, and hopefully there's somebody out there, if they're following the next point, has kind of documented their process. And you can read some random guy on the internet. You don't have to believe everything you read on the internet. Don't believe everything Ace says. But if you read what they're saying, a lot of times you can take one nugget of information. Everyone has some version or value of truth, right? And it may be that one piece of information you need. And then, like I said, the final point is write. Try to share what you've learned. I mean, I'll guarantee you, I write a lot. I mean, you can ask Ryan or even anybody from Synergex. You'll get these long ACE emails where they always start with two parts. There's the short and the long. And the short is usually like a little one-sentence thing that says, hey, if you did this, go run SVN update and it'll be fixed. And then there'll be the long section. And the long section kind of goes through my thought process of like, okay, this is what we ran into. This is why we ran into it. Here's MSDN documentation that says why this is a bad practice, or here's what I'm basing my thought process off of. And a lot of times, there are some developers that are like, oh, I don't care. I'm just going to read the short and move on with my life. But a lot of times, we'll see other developers come back to me and it's like, okay, Ace, I read that. I understand your thought process, but did you think about this? It's like, or, yeah, that's good. What about this? And a lot of times I learn a lot from that and they learn a lot from that. And, if we all put our minds together, we'll come up with a solution. So I can't encourage you enough, be active on Stack Overflow, be active on GitHub, be active on the Synergex Community Center. It's a great resource that's out there for you to try and communicate your ideas and what's going on. I mean, no question is too dumb. I mean, I can't tell you how many times I go back to that resource post where I posted, how do I get the build version on there? I go back to that like, I don't know, at least once a week because I can't remember. So on the concept of document, one thing I've really pushed for is a wiki. So internally, we run a software package called MediaWiki. So once again, it's free, it's open source. It's the exact same software that's used to power Wikipedia, so very scalable. It's super easy to edit, and then it also has version history. And I should have added a fifth bullet on here. Is that it's got full text search. So previously we used SharePoint. Don't ever use SharePoint. I'm a big Microsoft fan. There's only a couple products that I'll hate on from Microsoft. SharePoint's one of them. Here's an example. So I started making like a template that basically has got a four parts to it. So I have a short description of the issue, I have the root cause of the issue, and then I have a solution for it, and then a C also where I might have applicable things. Then I got this cool little box up here that says, hey, this was reported by me, this was reported back in 2017, and here are the versions that are affected. In this case, this was a Synergex bug, which was fixed. But basically, hey, when you're running our application, you encounter some error code, right? And it's like, well, what does this error code mean? Well, go down, kind of say, okay, this is a root cause here, link to where the cases are, so people that run into this can kind of figure it out, and then, solution. I can't tell you how many developers that see you are like, Ace, I ran into a problem, but because you took the time to go document it, I was able to figure it out, and I didn't have to go buzz you. I'm like, thank you so much for that. And I was going to say down here, so obviously this page has been accessed 17 times. I don't know if 17 people have ran into it. I'm sure some of those are refreshes, but continually documenting the process. Every error message you see, you're going to run into it again at some point. So further reading. So Joel Spolsky, like I said, 12 steps to better code. This was I would call it, this was an amazing blog post, and it's very old. It actually is from August 2000. And in here, he really lays out a lot of what I've talked about. And it's amazing. I mean, some of the references are dated. He's talking about like CVS and other technologies that have gone, but the concepts themselves are very, very still applicable. And I'll quickly read off his 12 points that he made. And actually, if you've ever gone to like Stack Overflow jobs, that little there's a little box down there that says, does this company pass the Joel test? And that's actually in reference to this blog post. So the first one is, do you use source control? Second one, can you make a build in one step? 3, do you make daily builds? 4, do you have a bug database where you're tracking bugs? 5, do you fix bugs before writing new code? I lost count, sorry. Do you have an up-to-date schedule? Do you have a specification? Do programmers have quiet working conditions? Do you buy the best tools that money can buy? Do you have testers? Do new candidates write code during their interview? Do you have hallway usability testing? And I won't go too much into his blog post because he explains every single one of those, and it's a really fascinating way to look at it. Another great post is it's actually a slide deck from Mark Windows, a software engineering odyssey, and this is another old post. This, once again, it came from August 2000. I don't know what was going on then, but apparently a lot of people were blogging about this. And he's talking about Microsoft's, their first big push when they were moving from Windows NT to Windows 2000, and just all the engineering issues they ran into, how they split out code, how they got continuous integration going on. And it's obviously a continuing process, right? I mean, we heard Donovan here just say they totally reinvented it, not even, 18 years later. Stack Overflow, great resource. I'm sure most of you have heard of Stack Overflow. Unfortunately, I haven't seen a Synergex tag yet, but maybe that's something Marty can work on, or post to the Resource Center. I use it as my personal Stack Overflow for anything Synergy related. I really like reading the MS Build tag because that's my world. I like to see what other people are running into, give my 2 cents. MS Build is another a great example of Microsoft. It's open source now, it never used to be, but you can interact directly with their developers. It's fascinating too. And then Donovan Brown, a really, really great keynote speaker. I'm so happy that he was able to come and speak to us. He's got a lot of great ideas, and you don't need to necessarily implement them all because it's very, very hard to do. It's a very long process. I mean, CU's been doing it for 8 years, and we're still doing it. And I would also say, if you ever have any questions about this, feel free to post on the Synergex Resource Center. I'm more than happy to answer in my off time. I love doing this kind of stuff. I'm really passionate about it. I love helping you as much as I can. So, with that, we'll put it off to questions.
This first one actually comes from someone at Synergex. Can you tell me more about your emerging technologies group? Is it as awesome as the name implies?
So, yes, the Emerging Technologies Group, it was a group that was formed right around 2000. So somebody got a bright idea in their head that said, oh, this is bad, I probably shouldn't say this, but I'll say it. We're tired of working in Synergy. Microsoft's got this really cool new technology, C# out there. We're going to start rewriting as much as we can in C#. And so it started as a small group of guys. probably like 4 or 5 that they pulled off and started writing a lot of C# code. And then all of a sudden it ballooned into this, I think it's up to like 40, no, not 40, that's too high, maybe 20 developers now, and they do all the new C# code. It's definitely the hipper group to work on, but at the end of the day, the money's made in Synergex, so the industrial group that I'm a part of and Ryan's a part of, we get it done.
How does CU incorporate manual testers into a continuous integration environment? Are there any plans to expand automated testing?
Okay, so one part I didn't talk about at all is CU has a huge manual testing world, and they're all driven off that MSI. They've got multiple virtual machines that every night it installs the latest build, a manual tester gets a work order, and then they start banging on their testing. But in addition to that, where I started out at in 2007 was the regression group. And what that was is that was an attempt, and I shouldn't say attempt because we actually did it, is a way to replace our manual testers with automated UI testing. So even every night too, we have tons and tons of automated tests. The problem is anytime you have an automated test, because you're manually clicking stuff in the UI, it's super time consuming. I mean, to do our full sweep of tests, I think it takes us a week. But as part of our release process, once we get closer to saying this is going to be the final one, we actually we run all those automated tests. But I'd be more than happy to show that and explain that to anyone. If someone wants to grab me, I'll show it off to you.
Since Subversion is working for you, what is causing the push to move to Git? And what will Git give you that Subversion will not?
Okay, so I'll give you the honest answer. The honest answer is, like any developer, when you see something brand new and shiny and you see everybody using it, it's like, I immediately got to get to Git. It's like, oh, this is the new hotness, everybody's doing Git, Subversion's old, I shouldn't use it, blah, blah, blah. That's going to be a hard question that we have to go down and look at ROI on it. For me personally, I'm actually a little more on the fence, and I try to keep an open mind about things because it can go both ways. You have to be willing to embrace new technologies. You can't just sit on your successes and be like, hey, I'm happy. Definitely evaluate new technologies, but as of this time, we haven't seen any like drastic, oh, we've got to go to Git. One thing that I always laugh about is if you ever look on GitHub, you'll see that there's actually a 1 gigabyte limit to any repository that gets uploaded. And I took one look at that. I'm like, we're going to blow right past that here with just one version. But anyways, long story short, I'll put something on ideas at some point that gives you our final decision.
Is there a way to get the deliverables to QA right away if that is needed?
Yes. So what will usually happen is when we get close to having a release, when we're really under the gun, what'll happen is an email will get sent out to distribution and said, hey, I found this show-stopping bug. Our drop-dead date is, at the end of the day, we need you to produce a build. So then that's when everyone gets like really anxious. They all start watching that build really, really closely. And as soon as that build is finished, our distribution group will immediately go build a new MSI. They'll manually kick off the process, and we call it a midday install, and we try to kind of avoid doing that because it kicks everybody off the system, but usually when that's happening, it's something pretty critical.
Incorporating previous sessions from this conference, could you give us a higher level overview on your Agile method and the different levels of testing?
Oh man, okay, so because CU is so big, every group has its own kind of little view on Agile. I can tell you what our group does. We're actually a Scrum-based group. We're a Kanban-based group. So the way we work is because we deal with support so often, we rely heavily on stand-up. So every morning we have, unfortunately, it's a 30-minute stand-up. That's one of the things I'm going to take back from this conference and say we should only have 10-minute stand-ups. They have like a traditional work order says, hey, this is what you're going to be working on today, try and address this, but roll with the punches. If something comes up, try to address it immediately. I don't know, my problem with Agile is everybody says Agile, and everyone's got a different view of what it is. I'd be more than happy to sit down and kind of explain exactly what our processes are, but every answer is going to be different. I mean, even Ryan's group is slightly different.
Thank you, Ace.
so
Please
much.
give him a huge round of applause.